So first let's define a zero of a function. So if y equals f of x is a function, then a zero of a function is a number at which the value of the function becomes zero. So if I take a number, and plug it into the function, so y equals f of x is a function. If I take a and plug it into the function to get f of a, and f of a happens to be 0, then a is called a zero of the function. It's a value at which the function becomes 0. So let's look at an example. Suppose the function is f of x equals x minus 2. This is a linear function. We want to find a value of x at which the function f of x equals 0. So f of x is x minus 2. I want it to be equal to 0. I want to find an x at which it would be equal to 0. I add 2 on both sides. Do you notice that we are solving an equation here? And x equals 2 is the number that will make the value of the function equal to 0, which means if I take f of x, which is x minus 2, and I plug in 2 into the function, I get a 0. So this is a 0 of the function. Now let's look at another example. I'm looking only at polynomial functions here. F of x, let's say, is x squared minus, let's make it a 4. So I want to find the zeros of this function, which means I want to find a value of x at which x squared minus 4, which is the function f of x, equals 0. So notice that again, we're going to solve an equation. A couple of ways of solving this. If you notice that this is a difference of squares, then you go x plus 2 times x minus 2, that's equal to 0. Now by the zero product rule, if a product of two numbers equals 0, then either x minus 2, the first number, is 0, or x plus 2, the second number, is equal to 0. So x equals 2 or x equals negative 2. Now, if we plug in 2 into the function, it is 2 squared minus 4, which is 0. If I plug in negative 2 into the function, I get negative 2 the whole squared minus 4 equals 0. Again, because negative 2 the whole squared is 4, positive 4. So either way we get a 0. So the two zeros of the function are x equals 2, x equals negative 2. Let's look at another example. Suppose we have f of x equals x squared plus 4. How do we find the zeros of this function? We take x squared plus 4, which is f of x, and equate it to 0 and find the numbers at which x squared plus 4 equals 0, which means we have to solve this equation. Subtract 4 on both sides. So we get x squared equals negative 4. Take square roots on both sides. Remember to do a plus or minus when you take square roots. Square root of negative 4. Notice that square root of negative 4 is not a real number. So x equals plus or minus square root of 4 times negative 1, which is equal to plus or minus square root of 4 times square root of negative 1, which is equal to plus or minus 2i. Remember that I, the imaginary number, I is defined by this, which is square root of negative 1. So notice that this is an imaginary number and the two zeros, so let's just plug it back in. So f of 2i is a 0. So 2i is a 0. When I plug in 2i into the function, I get 2i the whole squared plus 4, which is 2 squared I squared plus 4. We are using the rule of exponents. If we see a product inside the parentheses, each one gets squared. So that is 4i squared plus 4. Notice that if I is square root of -1, I squared equals -1. So this would be equal to -4 plus 4, which is 0. Similarly, f of -2i is also equal to 0. Now, what we've seen here is that the zeros don't necessarily have to be real numbers. Zeros can be imaginary numbers as well. Now, the value of a function at a 0 is equal to 0. So if you look at this function here, notice that, let's call this 1, 2, 3. So if this is a function y equals f of x, then f of 1 equals 0, right? So this point is 1, 0. So this is x and this is f of x, your x and y coordinates. So the value of the function equals 0. So these are the x-intercepts. So here again, if you plug in a 3 into the function, the value of f of 3 equals 0. So this is 3, 0. So notice that the real numbered zeros, if we have zeros that are real, those are the same as the x-intercepts of the function. Okay. Now, if you have a complex zero, you're not going to see that on the real number line, but if it's a real number that makes the function equal to 0, that's the same as x-intercept. So real zeros of a function are the same as the x-intercepts of the function.